Hi, this is Jason Baker, and welcome back to our lecture on container orchestration. I've talked about a couple different container orchestration platforms that are available in the marketplace, things like ECS and Fargate and Kubernetes. Now I want to talk a bit about Docker Swarm, and I'll spend the rest of the lecture discussing the Docker Swarm orchestration platform. So Docker Swarm is basically a cluster orchestration service that is integrated into the Docker engine. And prior to version 1.12 of the Docker engine, the Swarm service was a separate tool called Docker Swarm. But today it's integrated with the engine, which means that when you install the Docker engine on a server, then Docker Swarm is also automatically installed. So instead of calling it just Docker Swarm, technically we call it Docker Swarm mode. And what Docker Swarm mode allows you to do is it allows you to create a cluster of instances that are all running the Docker engine. And each of these instances are called cluster nodes. There are two different types of nodes that you can create in a Docker Swarm cluster. There are manager nodes and worker nodes. You define the type of node that you want when you are first deploying the nodes within your environment. So each cluster node is either going to be a manager node or a worker node, and you define that at deployment time. And what's cool is that you can use the same image. So when you set up a Docker node, a Docker Swarm node, then you specify whether it's a manager or worker, and you don't have to use different software or a different image to do that. Docker Swarm follows a declarative approach in terms of its management of containers. So when you're defining the services that are going to run in a Docker Swarm cluster, you're defining a desired state of those services. And Docker Swarm mode will monitor the state of the cluster and continuously help you try to achieve that desired configuration state. Here's how the cluster looks. So as I mentioned, there are manager nodes and there are worker nodes. Typically, you have to have at least one manager node in the Swarm cluster, but typically there are multiple manager nodes and and usually at least three manager nodes because the manager nodes will store the internal configuration state of all the services in the cluster. And it stores those using the raft algorithm. So they're stored in the raft logs that are distributed across each of the servers. And if you recall how the raft algorithm works, you need to have a quorum of servers available. So you'd want to have at least three manager nodes in a typical um, Swarm cluster environment. And then the manager nodes will communicate with the worker nodes. And the worker nodes can find one another, and they do that using a gossip protocol to exchange information. So the workers are all kind of communicating and updating one another as well. In terms of security, all the communications that occur between the manager nodes and the worker nodes inside the Swarm cluster, those communications are all encrypted using TLS. So there's a management backplane a management data backplane where the manager nodes are communicating with the worker nodes and scheduling the running of containers and in some cases providing secret information. And so all that entire management data backplane is encrypted using TLS. So how do you create a cluster using Docker Swarm mode? Well, first of all, you start with a set of instances, one or more, like EC2 instances that have the Docker engine installed, and it has to be at least Docker engine version 1.12 or above. And so once you have a set of instances that are running the Docker engine, you take one of those instances and that's your first node in the cluster, and you initialize a new swarm cluster by running the Docker swarm init command. That will initialize a new cluster and make that first node the first manager, or the first leader of the cluster. So if you have multiple manager nodes, one of those manager nodes is going to be considered the leader. Because remember, the raft algorithm uses a leader election process to elect a leader, and there has to be at least one leader at all times. So once you initialize that cluster, you have your first manager leader node. Then the the Docker Swarm then will generate two tokens, and these are just two long alphanumeric strings. One of which is a manager token, and the other is a worker token. So what you do then is you go to the other nodes that you want to join the cluster, and you can run a Docker Swarm join command and provide either a manager token or a worker token. And that will then connect the subsequent nodes to the existing cluster. And it will designate each node that's joining the cluster as either being a manager node or a worker node. One of the challenges that you encounter if you're trying to automate this whole process, the bootstrapping of a new cluster, is that first you have to create your initial manager node, and then you have to tell the additional nodes where to find that that manager node. So there's a sort of a service discovery step that has to take place there. And there's a variety of ways to accomplish that. So we have two different types of cluster nodes then that are running within the cluster environment. We've got our manager nodes and our worker nodes. The manager nodes are doing a couple different things. They're constantly monitoring the state of the cluster, and they're reconciling the differences that occur between the actual and desired state of the cluster. If you have like a container that's running in the cluster and the container fails, then it's likely your desired configuration state is no longer being met, and so the manager nodes are responsible uh, for noticing that situation and then and then resolving it by like creating a new container and or restarting a container. The Swarm Manager nodes provide a service discovery function. So when you're defining these things called services within the cluster, the Swarm Manager will actually kind of manage DNS settings and also provide an ingress load balancing capability to distribute requests across containers running within the cluster. And I'll talk a little bit more about this here in a bit. And then finally, the swarm managers will handle the updating of containers within the cluster and allow you to perform rolling updates of containers so that you can progressively roll out a new Docker, new Docker containers running an updated version of your container image. The swarm worker nodes uh, don't have to do much other than just run Docker containers. So they're the sort of the landing point for Docker containers within the Swarm cluster. And they will communicate with the Swarm manager to update the manager as to the state of the containers that are running on the worker node. Now, Swarm manager nodes can actually serve as workers as well. So they can serve a dual purpose role. You can run and schedule the running of containers on managers. However, in a production environment, generally we don't recommend doing that because there's the potential for, like containers running on the manager nodes uh, to to consume available CPU resources and essentially starve the orchestration service so that it can't perform optimally. When you're deploying services into a Swarm cluster and deploying containers into the Swarm cluster, you're not deploying containers sort of directly. You're creating what are called services, and you can think of services as being an abstraction layer for Docker containers. So a service represents a Docker container that's going to be configured in a particular way. And oftentimes it's not just one Docker container, you're going to be deploying multiple copies or what we call replicas of a particular container. So you create a service definition and you provide that service definition to a manager node in the cluster. And then the manager node takes that service definition and it dispatches tasks to workers. You can think of a task as being a, a Docker container and and any commands or configuration settings required to run that particular container. And there's two different service models that you can specify within a Swarm cluster environment. You can configure services as replicated services or global services. When you configure a service as a replicated service, you specify a specific number of tasks that you want to run within the cluster. In other words, you would create a service to run something like an Nginx container, and you can specify how many Nginx containers you want to run within the cluster. Maybe you want to run 3 Nginx containers within the cluster. So you would set it up as a replicated service with a replica count of 3. And then the Swarm cluster would automatically launch 3 Nginx containers for you, and it would figure out optimally where to run those containers within the cluster. You can also set up services to run as global services. With a global service model, the Swarm cluster will run a single task or a single container on every single node within the cluster, generally every single worker node within the cluster. And this might be useful for sort of scenarios where you need to run one service of one particular service on every single node within your cluster environment. And that could be something like a log service. Maybe you're running something like you're running something like maybe an elk stack within your environment, and so you need to run a log stash container on every single node. Or maybe you're running some sort of monitoring tool. So you're going to run a monitoring container on every single node within your environment. So you could define that as a global service, and then the Swarm cluster would ensure that at least one container is running on every single node within the cluster. One of the big benefits of a container orchestration platform is that it can, to a great degree, automate the management of networking. And it can help you connect containers to one another. So in a Docker Swarm cluster, you can connect different services together using what are called overlay networks. If you recall back to our discussion on Docker networking, I'd mentioned that there are a couple different Docker networking drivers that are available. An overlay driver is the one that we use within a, a Docker Swarm cluster. And what an overlay network does is it basically allows you to create a layer 2 network, which spans multiple cluster nodes. Because remember, Docker containers are basically running within a private network. And in the case of a Swarm cluster, we're not just dealing with a single EC2 instance, we've got multiple EC2 instances. And so we need a way to be able to run containers within a Swarm cluster. And these containers are all running on within a private Docker network. We need a way to be able to connect all these containers together. And so we can create, using the overlay network, we can create this layer 2 network, this virtual network, which spans across all of our EC2 instances. Essentially, from the perspective of a container, then that's running on an overlay network, it can communicate with other containers within the Swarm cluster, even if those containers are running on different EC2 instances. From the perspective of the container, there these all these containers and various services are all kind of running on the same network. And when you configure these overlay networks within a Swarm cluster, you can configure multiple overlay networks. The key is that if you want two services that are running within the cluster to communicate with one another, those two services have to be associated with or attached to the same overlay network. If the two services are on different overlay networks, then they will not be able to communicate with one another. And that's a way we can sort of effectively partition our services. If we have, because there might be cases where we don't want two services to be able to communicate with one another for security reasons. The services that we create within the cluster, they have to join at least one overlay network, but they can join multiple overlay networks, so they can communicate with different services that are on different overlay networks and be attached to multiple networks simultaneously. The the, the Docker Swarm platform provides us with a built-in service discovery mechanism, which is a really important part of a container orchestration platform. Because when we're launching services into the cluster, these services are going to be running on different hosts within the platform, and we need some way to be able to tell a service where to find another service that's running within the platform. Because remember, we're not hard coding IP addresses, right? We don't actually know where our services are going to run within the cluster, because the orchestration platform, Docker Swarm, is taking care of all that for us. It's dynamically, launching and creating these containers, and it's going to run them in an optimal fashion. But we don't have much control over where it's going to run them, nor do we really care where it's going to run them. We just want our containers to stay up and running and be performant. But when we're launching services, generally we want our services to be able to communicate with one another. So, for example, we might have a web application server that needs to communicate with a database service. We have to be able to tell the web application service where to find the database service so that the application can open up a network connection to the database server. So in a Docker Swarm platform, this is handled really elegantly. So anytime we create and define a service that's running within the Swarm cluster, that service, the Docker Swarm will automatically create a service name for us in DNS for each of the services running in the cluster. And it will also create a virtual IP address for each of the service. And the containers then will discover this DNS information using the Gossip protocol. So what does this mean in a nutshell? Well, if I'm creating a service called web service and I'm creating a service called database service, I can tell the web service to communicate with the database service just by using the service name. So in my application, when it needs to know the database service endpoint, I just refer to it using the service name, which might be something as simple as database service. And my application will automatically be able to find that database service because Docker Swarm is setting up essentially like a DNS host record, an internal DNS host record, which only exists within the Swarm cluster, which magically connects and maps that service name to the virtual IP address. And when my application communicates with the virtual IP address, it will be routed then to one or more replicas of containers in my service. So it's a very, very elegant way to kind of wire up applications to communicate with one another. Now, when you're deploying services and deploying your application containers into a Swarm cluster, it's important to note that by default, those services are only accessible within the cluster. So one service within the cluster can communicate with another service within the cluster as long as those two services are running on the same overlay network. But if I'm trying to access a service that's running within this Swarm cluster, if I'm trying to access it from the internet somewhere, or I'm trying to access it from outside of the cluster, I won't be able to do so by default. All of those services that I create, all those containers, applications that are running in the cluster, by default are only accessible within the cluster. If I want to make a service that's running within the cluster accessible to the outside world, then I need to expose a port. I need to expose a service port. And then that will make a service and the set of containers that are running as part of that service, will make that service available outside of the cluster. And what's really interesting is that when I publish a service port, Docker will automatically set up an ingress load balancing capability. It's something called the ingress, or it's something called the routing mesh. and it will use that to automatically distribute requests to the service tasks, or the different containers running on nodes within the cluster. So you can think of this as being like an elastic load balancer, or a load balancing service that's automatically created for us when we publish a service port. And what's really interesting is how Swarm actually goes about doing this. What Swarm will do is it will publish that service port to every single node within the cluster. So essentially every node in the cluster is listening for requests on that service port. And if a node receives a request on that port, then it can automatically redirect that request to a container for that particular service. And so why that's really useful is that we don't need to know where a service and its containers are actually running in a Swarm cluster. We can just simply use something like an elastic load balancer that's listening on a particular port, like let's say port 80 for HTTP traffic, and our elastic load balancer then can distribute that port 80 request to any one of the nodes in our cluster, and then the Docker Swarm will use this ingress load balancing service to automatically redirect that request to the container, one of the containers of the service which is publishing that port. And so it solves kind of a big problem for us, and it makes routing requests into the cluster really easy. Here's kind of a diagram showing how this works. So in this case, we have a we have a service that has two different tasks, and those tasks are publishing a port, which is port 8000. So every single host in the cluster, every single node in the cluster is going to listen on port 8000. And if it receives a request on port 8000 from something like an external load balancer, then the host will automatically redirect the request to one of these running tasks. You notice that this third host, which is labeled host C, doesn't have one of these tasks running. In other words, we've created a service. This service has two replicas, two tasks, two containers. And so this third host doesn't have one of the tasks running on it. But that's just fine. If the third host receives a request on port 8000, it knows where those tasks are located, and it can redirect that request to one of the other hosts. And those hosts then will redirect the request to the proper container running on that host. It's a very interesting, very elegant solution, and it makes working with this swarm routing very, very easy. When you're running the services within a Swarm cluster, you define a service, and you specify whether it's going to use service replicas, or if it's going to be a global service. If you're running service replicas, you specify how many replicas, or how many containers you want running for that particular service. And you can scale that number up or down over time by specifying a scaling attribute for the service. So you might start out with like a web server service that has 3 Nginx containers, and maybe you want to dynamically scale that up or down based upon demand. And you can easily do that by just simply changing that service definition, and then the Swarm orchestration platform will make changes to the number of running containers to meet your desired configuration states. You can also drain nodes within the cluster. So you might have a node in the cluster that you want to shut down for updating or maintenance purposes. And so you can tell Docker Swarm that you want to drain or you want to remove all of the containers that are running on that particular node. One of the other things I'll note is that if you launch a new node, and let's say you have an existing Swarm cluster where you're running various services, and you decide you want to add more capacity to the cluster by adding another EC2 instance and adding another worker node, you can join a new worker node to the cluster, but the Swarm orchestrator is not going to automatically like rebalance the cluster or move some of the existing containers and move them to the new worker node. You have to forcibly rebalance the services that are running in the cluster in order to do that. You can update the services that are running in your cluster. Maybe, over time you're making application changes, so you're building new Docker images, and you want to be able to deploy those new images into the Swarm cluster, and you want to be able to update services, and you can do that pretty easily using Docker Swarm. Docker Swarm uses a rolling update methodology. So it's sort of a canary deployment, rolling deployment process. And there's a couple different parameters you can set. You can specify how quickly uh, Docker Swarm will update the containers in a service by specifying an update delay or specifying a parallelism setting. Um, you can also specify what Docker Swarm will do if it encounters failures while trying to update the services running within a cluster. And if you update the services in a cluster, and if you need to, you can roll back to the previous container very easily, and that's a built-in feature. And then one of the final things I'll talk about is the management of secrets. Um, and this is always a challenge. How do you provide secret information to the services and applications that are running within your Docker containers? What's a secret? Well, a secret, is something that you want to keep secret, right? It could be like application credentials. Maybe it's a username and password that your web application is going to use to talk to the database server. That might be really secretive sort of information, and you want to make sure that that information is stored securely. Well, Docker has a secure sort of vault service that's built into the Docker Swarm platform. It's an encrypted key value storage mechanism that you can use. So you can essentially create key values and store those within the Swarm Manager nodes. These values are encrypted while at rest, and then these values are encrypted in transit when they're communicated from the manager nodes to the worker nodes. When Docker launches a service, then you can tell the Docker Swarm that the service needs to be able to access secrets that are stored within the cluster. And what Docker Swarm will do is it will actually mount a temporary in-memory file system to each container that's created by a service. So within the container itself, you'll see this directory structure that's run at /run/secrets/secret name. And then the actual secret is stored the secret is stored as a text value. So the secret name is like a file, which is the key for the secret, and the value of the secret then is stored as text data within that file. And that's created when the container is launched by Docker Swarm. So you can then configure your application to look for a value like the database username or the database password. It can look in its own file system to get that access information. That way you're not hard coding secret credentials into your Docker image. You're not storing this as clear text somewhere. It's stored securely in encrypted format in the in the cluster, and then made available to services and containers as they launch.